Ladies and gentlemen, today we have small television. It's a Delcon something or other. It's a black and white monochrome and she does not work. There is some sound but no picture. There's adjustments for brightness and contrast and this and that, but no matter what I do, it seems to be dead. I took out all the screws, but I'm stuck. I just took some wiggling and persuasion because of this thing. And now yay. That's no fun. The transformer is in there and the connection to the battery and the speaker, so we might have to desolder that, but for now I think we can work on it like this. It's a lot of unpopulated space and dust on the board. Must have been several versions of this thing with more features. This doesn't look too promising. The flyback has a crack on the plastic, but maybe that doesn't mean anything. Surprisingly little stuff in this thing in general. I powered it on and I don't see any glow in the CRT. I forgot to check the other side of the board. Sometimes there's obvious issues like cracked solder joints. This is kinda cool. They shaped this PCB trace to be like an inductor or a resistor or something. I'm checking one of the deflection coils and ooh, that's interesting. I was getting nothing, but obviously it's trying something now. Checking the other deflection coil and we do have something. So I suppose this is the horizontal deflection and it is doing stuff. 26 Hz. That's not high. If this is anything like really old televisions that I've seen before, everything like the high voltage will be generated by the flyback transformer, which runs from the horizontal oscillator, including also the filament voltage for the tube. So if something's wrong there, that would explain everything. I found a schematic of what the horizontal output stage of a TV usually looks like. This is approximately it. We have the flyback transformer, which is this thing. And as I thought, the filament voltage comes from there, and the high voltage, and some other stuff. So the flyback transformer is driven by the horizontal output transistor, which we can easily find because it's a big transistor and it's gonna be near the flyback, and there is only one. I took out my differential probe because I'm not really sure what's what and I don't want to blow up my oscilloscope. You can pretty much assume that the outside of the tube is grounded though. So that's that. So this is that transistor. This pin is the one that's connected to ground, so that would be the emitter. And this one has to be the collector because it goes to the flyback. And if we probe that, you can see there's some stuff going on. This also makes me think that the deflection coil we were checking earlier that had something going on isn't the horizontal one. And this also doesn't look quite right. We should be seeing like a 15 kilohertz sawtooth wave, which is not what we're seeing. And this one should be the base. And if we probe that, the level is a lot lower, so we're seeing this, which doesn't really make sense to me. Yeah, I can smell something burning. I added some wires so I can power this thing from 12 volts. It has a connector for the input, but I put those wires there before I found this one back. I don't know how well this schematic matches what's on the board, because this is just generic, but at least we seem to also have this transformer. There's a little transformer down here, and it also connects to the base of that output transistor. So I think the next step is to find where does the input to that come from, or how does it work. Apparently we can just take this board out by pulling it before we go much further. I want to make sure that this tube doesn't hold a charge. I don't think it does. The dangerous thing about televisions when they're powered off is that this whole tube acts like a capacitor. There's a conductive coating on the outside and the inside, and since the inside part is charged to a high voltage, you can get quite a nasty shock. And the way you can deal with that, and this is probably ill-advised, but get a screwdriver, try this all at your own risk, clip a cable to it, and we clip the cable to whatever's connected to the outside of the tube, and then just have to jam the screwdriver under the anode cap and make sure that you're not touching it, and make sure that it's like an insulated screwdriver. As ESD safe ones, they're no good, they're conductive, you'll still get zapped, and this one really isn't good enough either, but yeah, I like to live dangerously, I guess. And there's a little metal clip in there you have to make sure you touch. I'm gonna get this off so I can get a better look at the board without the tube in the way. This is usually just a small metal springy thing. If you're working on a color television, I'd advise not to mess too much with these things, because they're really tricky to adjust. With the black and white ones, it's not so bad. Spared no expense. The best of materials are used. Since I can finally read this, let's take a look. What's this thing? It is one chip for B/W TVs. And I believe we'll find where that horizontal oscillator comes from. So there's all this blah blah blah. And there is a typical application circuit. I would be surprised if they changed this a lot. Of course, the first one we find is a little bit too blurry to read. This one is much better. It's another datasheet for the same part number, but from another manufacturer and from someone with a better scanner. And this is the flyback transformer. Then we have the horizontal output transistor we looked at earlier, and the small transformer. Also, there's the transistor that was in the schematic that we were looking at. And this is where the horizontal drive comes from. Goes right to that transistor. And the oscillator itself seems to be done with some extra passives around this chip. So I think we should look over here at pin 17, see if the problem is somewhere down the line, or whether the oscillator isn't starting properly. And since we don't have the CRT connected, we should be careful that this thing isn't touching the board or myself. This thing is still grounded, so I can leave this as is. Otherwise I could clip the ground here. Of course, I'll have to check if the problem is still there. Nothing's happening, but yeah, I accidentally turned it off. Not using an excessive amount of power, that's also something good to know. See, this is where we were originally probing, and we're still getting that weird stuff. And now we know somewhere here, yeah, I think this one, is pin 17. So this is that horizontal drive output, and it's pretty unstable and it's way too low frequency. And this is pin 18. I don't know exactly what we're expecting to see, but this is probably not right. So there's funny business going on at this pin 17 and 18, and I suspect this pin 17 is just an output that drives this transistor and so on. But this pin 18 is part of the oscillator stuff, and I don't know exactly how this oscillator works, but I don't think it matters. The problem almost has to be something with all these passives here. It could also be something to do with the vertical oscillator, but I kind of doubt it, because at the vertical deflection coil we see like a 25 Hz signal, which is perfectly normal. At least it's a perfectly normal frequency, but we should be seeing a stair step, which is probably why these are connected, but I'm not quite sure. So I think we should just go and check components. Maybe this potentiometer is just dirty and not making contact. That'd be too easy. Maybe this capacitor has gone leaky. This is that potentiometer we were talking about, and if I probe that horizontal output and look at it on the scope while I turn this, nothing changes. However, if we measure the two outside contacts of that potentiometer, we get 20 megohms, which seems a lot higher than it should be. And between the center and the one side we get 800 kiloohms, and between the center and the other side we get 20 megohms. That's not right at all, especially since this is set approximately to the middle. I wouldn't expect this to match the schematic we have exactly, because that's just a typical application type schematic, but it should be somewhere closer. I couldn't read this easily, but this green light helps my eye. I don't think it helps the camera. It says 10K, so there is our problem. Of course I don't have the same thing, but I have a similar one. The pins are a bit different, so we'll have to figure something out. The center pin on this is connected to the outside, so I think I'm just gonna clip it off and solder a wire somewhere there. I've already placed the wire in the PCB. Yeah, of course I destroyed the potentiometer. This time I added the wire first, hopefully that works out better. Not the prettiest thing in the world, but I think it will work. And I'm gonna reconnect the tube before we power it on, because I'm confident it will work. Uh-oh. Angry meter wants to save its battery. Yeah. Alrighty, moment of truth. Yay! It's alive! We did it! Very nice. And of course I'll have to get a picture to align this properly, I guess. And this. Yeah. This way we can at least see if it's pretty much straight. I think this is fine. I can feel where it used to sit. So I got the cable that comes from the wall with the TV signal, and we have a picture, but it isn't perfect. Let's see what happens if we adjust this horizontal hold. It's either fucked or it's not. So somewhere in the middle it's nice. I don't know why the picture is too short. Ooh. Something's not happy. Maybe because it's not sitting right. So the sound is very quiet. Let's see, what does this potentiometer do? This is a terrible idea usually. But there's only 3 potentiometers in this thing. How hard can it be? Huh. Okay. I'm confused as to what these do. Uh-oh. Oh shit. It was drawing 3 amps, that's not right. Not good at all. Maybe I shorted something. Ugh. Oh! What happened is, I have the power coming in like this, and these two were kissing. Yeah, why is our picture squished? What's this? More high quality materials. The example schematic does have a vertical size adjustment, and we'll find that one by following pin 25. Should go through some capacitor and then resistor. So that is this one, and can you guess the problem? I took this one out and it's entirely bad too. What are the odds this one is good? I improvised something to figure out what resistance we need since I don't have the right part. And it's still a little bit too narrow, but if I add another one, there we go. That looks about right. I don't have a test pattern generator, so this is gonna have to do. There's my resistor, 91 ohms, apparently is good. It looks like this now. And I kinda wonder what this one's for. The only other one I can find on the schematic is for vertical trigger, or whatever that may be. Maybe that is this one, because when I messed with it, it did mess with the vertical. Or something. If I'm not wrong, all this unpopulated stuff is for a color version of this TV. since it says a lot of colors: black, red, white, green, and that'd be super cute to have such a small color TV. The controls on the back at least seem to work. The contrast is not very responsive, but it does work. So as you can hear, the sound is quite silent compared to the static. So I think something's wrong with that still. But I don't think that one's to blame. Not quite sure what is the problem. I'm gonna call it quits for now, because I don't really plan to use this as a television. I might repurpose it for something. So this is good enough. I'm gonna clean off the dust and put it back together. And Viola, the tiny television works again. I'm happy with that. Thank you for watching and goodbye.